Guys, it's Miss Landry here, and I am going to be talking to you today about experimental design. The critical thinking piece will come on the second video, so let's get started. Don't forget that you have a test next week. We call it a quest because it's a smaller version of a unit test. It's 50 points, so it's half of a regular test. So it's kind of between a quiz and a test, hence the quest. If you need extended time on the test, please come and talk to me before the test is given on Wednesday so we can set up something that works for you. Today we're going to talk about the essential elements of experimental design, and then the next video will be about consumer information, how to be critical when you read that. Your homework is a TED Talk and reflection that's on Canvas, and then also start reading mods 6 and 8 and taking notes to submit to Canvas. All right, let's get started. Let me clear that off. So research always involves variables. So you might be asking yourself, well, what's a variable? And just think about the term. A variable means changing, right? So in that case, let's take a look at this study right here. Whenever you're looking at a graph, it's very important that you look at the axes. So here we have test scores, and here we have, well, I don't know what, it just says chose laptop and chose handwritten. So what do you think the variables tested in this experiment were? Pause and answer that question. Okay, so it actually measured both the test scores they took and whether they took notes on a laptop or handwritten. Now, we'll talk a little bit more about this when we get a little further into cognition, but some of it I think has to do with the fact that we haven't really taught you guys how to take notes on a laptop. So whereas you've had a lot of practice handwriting notes, but we'll talk about that in the future. So those are the two variables. So your graphs are always going to have your variables on it. So why do we do experiments? Like, what's the point of doing an experiment and why are they important to science? And I happen to love experimental design. I think it's an art form. And the better you are at it, the more you're going to get paid if you become a scientist. That's always good. They are, so think about common sense, right? How many times have you guys thought of something that made total sense and like you inferred something and then you found out it was incorrect? We could actually go back to our learning day when we did that sort of different ways to study. If you remember, it seems like reading your notes and highlighting is a really good way to study, but you found that it was actually very ineffectual. So that's an example right there, okay? Experiments, so we're gonna talk about two different types of, I don't know how to say this, but relationships, I guess. One is correlation and one is causation. Correlation is when it looks like the two variables are related. So as one goes up, the other one goes up. As one goes down, the other one goes down. Or as one goes up, the other one goes down. But that does not mean the same thing as causality. So causality is when A causes B, when smoking causes lung cancer, when lack of sleep lowers grades, that kind of thing. So that's causality. That's very different from correlation. So we have two types of variables that are really important in an experiment. The first two you're going to learn about. One is measured and one is manipulated. You can kind of think of manipulated as the capital M and then measured as the little m, okay? A manipulated variable is called the independent variable. Got it? Independent. Notice there's an I in manipulated right there. Whereas measured is the dependent variable. So it's going to depend on what you do to the independent variable. And it's always measured. And don't worry, we're going to go into some examples of this if you're not quite understanding it. So let me clear that again, sorry. So the independent variable is what you as the scientist are going to manipulate. So it's what you are going to change in the experiment. The dependent variable is measured to see if there is a change in it because of what you changed in the independent variable. This sounds more confusing than it actually is. So let's do an example. I think that's going to help the most. This just shows that the causation, right? So we're hoping that we're going to show that there's a causation or a causality between the independent variable and the dependent variable. We can skip that slide. Okay, so here's an example. I happen to love Cheetos. But I notice that when I eat a lot of Cheetos, my hip circumference increases. My hips get wider. And so as a scientist, I think to myself, wow, I should really do an experiment to see if that's true. So I have to come up with a hypothesis, right? So the first thing you do is you ask a question or do an observation, and then you're going to form a hypothesis. So here's my hypothesis, okay? Eating Cheetos will increase your hip circumference. So what is the IV, the independent variable, and what is the DV, the dependent variable in this hypothesis? Pause the video and answer that question. All right, so here you go, okay? If I change it to the more Cheetos you eat, the wider your hips, well, then the independent variable is going to be how many Cheetos you eat. And boy, this guy looks like he's eating a lot. I don't know if he's going to eat those or if he's just bathing in it. I think that's probably one of those YouTube videos. And then my dependent variable, the one I'm measuring, which made it easy with a ruler there, is hip circumference. So independent, I'm going to change in different groups how many Cheetos are eaten. And then I'm going to measure hip circumference as my independent variable. Okay. When you write a hypothesis, you have to state the relationship between the two. All right. So if you remember, I believed that the more Cheetos you eat, the more your hip circumference will increase. So it's basically a positive correlation and a positive causation, right? So eating Cheetos is going to cause the hip circumference to increase. So let's try a couple practices of identifying variables. So here's the question, or here's the hypothesis. If rats are sleep deprived, they will have a lower will to live. That's so sad. Okay, pause the video and answer the two questions. What is the independent variable in this? And what is the dependent variable? Okay, so the independent variable is how much sleep they're getting, right? Because you as a scientist are going to change the amount of sleep that those rats get. Lower will to live is going to be the dependent variable because that's what you're going to measure. Now we'll talk a little bit about in just a bit about how do you measure that, because that's kind of a weird thing to measure in a rat, but we will talk about that. Here's another example. If a person diagnosed with depression takes medication A, then they will express fewer symptoms of depression. Okay, so pause the video and answer the question, what is the independent and what is the dependent in this hypothesis? Okay, so welcome back. So in this case, and you might want to get into a good habit if there's a question on the test about variables, just kind of underline it in the hypothesis, okay? So they're diagnosed with depression and they take medication A. So whether or not they take medication A is going to be your independent variable. And then the amount of symptoms they show is going to be your dependent variable, what you measure. Pretty simple. I can certainly give you more practice if you're struggling with this one a little bit. There's some key elements to a good experiment. Okay, before you go on, take a minute and in your notebook or with the Edpuzzle, go ahead and write down as many things as you can think of. Okay, so here they are. This is a lot, right? So you should have a question or a theory or hypothesis. You should have what's called an operational definition of variables, and we're going to talk about that next. We're going to talk about how you figure out how to get your samples, so the people that are going to be in your experiment. We're going to talk about the difference between an experimental group and a control group and the importance of replicability. Can you repeat the experiment and get the same results? We're going to talk about confounding, oops, sorry guys, hold on. We're going to talk about confounding variables, what those are. And then finally, we're going to talk about stats. So let's keep going. Let me erase that for you. All right, let's go back to our question. If you remember, I said, how would you test this? So eating Cheetos increases hip circumference. Or if I put it in an if then, if you eat more Cheetos, then your hip circumference will increase. So I want you to think about how we could do this. I would probably think you could make a bunch of groups of people and they all eat different amounts of Cheetos, right? And then you're going to measure their hip circumference. So this group might get no Cheetos, wouldn't want to be in that group. This group gets 25 Cheetos a day. And then maybe this group gets 100 Cheetos a day. So we have 3 different groups here, right? And then what we're going to do is measure their hip circumference at the end of a certain amount of time. That's probably how I would do this experiment. Pretty simple. But we need to have an operational definition of both variables, okay? It has to be measurable and it has to be specific. So when I talk about Cheetos, I have to talk about amount of Cheetos, right? And it has to be specific. I can't just say they eat some Cheetos or they eat no Cheetos. I want it to be a specific amount. And when it comes to hip circumference, I might measure their hip circumference, but I might then take it as a percentage change because everybody starts with a different hip circumference. So I might measure this, but then change it to percent change in hip circumference. If you've ever seen Biggest Loser, that's what they do. So when they lose weight, they don't measure total weight loss, they measure percent change in body mass, if that makes sense. So if you look at this one here, we talked about low self-esteem. Maybe there's a test you can take, and we look at how the person scored on that test after taking medicine or not taking medicine. In the one about the rat, where we said if they didn't get sleep, they would have a higher or less of a drive to live. So how do we actually measure a will to live? So maybe we look at how long it'll swim in a bucket before giving up. Gosh, that's terrible. I would not want to be that experimenter. But hopefully that kind of clears up what I mean by your variables have to be defined, both measurable and specific, okay? Replication is really important. So if I do an experiment on, let's say, a new drug, and I find that it worked really, really well for, I don't know, depression, and then another group, another lab tried the same experiment, and they did not get the same results, then I can't really trust it, right? Because maybe something was wrong in mine, maybe something was wrong in theirs. But in order for this study to be accepted, it has to be repeated, and repeated with the same or very similar results. So it has to be in a controlled situation, meaning you can control what the people are doing, which is really hard in a human study. It has to have those operational definitions of the variables, and it has to be repeatable. Those are key. That's it for this video. Take a break before you start the next video. I have a few multiple choice questions for you guys to try. It's on Canvas, and then hop into video number 2, and that'll be it for today. Thanks, guys.